Stephanie Kwolek was born in 1923 to Polish immigrant parents. She developed a love for design and sewing from her mother, and her father fueled her curiosity by exploring the outdoors with her as a child. In grade school, she commented on her male classmates envying her due to her excelling in her math and science courses. Her father passed away at the age of 10, and she had to fund her education at Carnegie Mellon University, which was an all women's college, to get her BS in chemistry. Kwolek said she was inspired by her women professors' enthusiasm for chemistry, as women didn't typically pursue this field. During her time in college, in her undergrad years, she was offered a position to work in a research lab at DuPont University to study polymers. She may have been offered this position due to many vacancies during the World War II because many male workers were deployed. But she did great at this job, and upon graduation, she was offered a full-time position to study synthetic fibers of extreme durability under less extreme reaction conditions that were previously known.
So yeah, Stephanie developed this particular fondness for polymer research during her time at DuPont. She began her work developing these low temperature processes which created petroleum based synthetic fibers. In order to generate fibers of these extraordinary rigidity under milder conditions, she turned to aromatic polyamides. She began by dissolving these amides into a solution she likened to molasses due to its very viscous nature. So her research led her to discover that under these low temperatures, the polyamides would actually line up by the hydrogen bonding between the carbonyls and the amines, which is actually comparable to beta sheet structures in proteins. This caused a reduction in entropic nature. So instead of a viscous solution that she had previously noted, this solution was actually cloudy and more fluid. Her colleagues were like, oh, that's never going to work, but she insisted and spun the fibers anyway, and this gives us modern day Kevlar, which is very important. As you can see, it protects our doggy friends. This reaction mechanism is a condensation polymerization. It is a nucleophilic carbonyl substitution mechanism is through the para-substituted dicarboxylic acid, aka terephthaldehyde. It is, like I said, a condensation polymerization, and the official name is poly-p-phenylene terephthaldehyde.
Yep, so as Lauren said, the polymerization causes a decrease in entropy as the number of molecules are being reduced, which is an unfavorable process. To ensure an overall favorable process, a lower temperature should be used to make sure that the enthalpic contribution is the dominant one. But since this reaction is a condensation reaction, the entropic contribution isn't as high since because water molecules are being produced. So the reaction can be described as the amine functional group plus the carboxylic acid functional group to produce the polyamide and water. And the rate of this reaction can be described as the change in the polyamide concentration over time, which is equal to the negative change of the amino functional group over time, which is equal to the negative change of the carboxylic acid functional group over time. And this can be reduced to the rate is equal to the rate constant times the amine concentration times the carboxylic acid concentration. So since the amino and the carboxylic acid functional group are on the same molecule, the rate equation can be reduced to the rate equaling the rate constant times the polyamide concentration squared. So this reaction is a second order because the two contributions are of the same molecule.
Yeah, so Stephanie led a life obviously rich with honors and distinctions up to her retirement in 1986, even after which she was mentoring young women into the pursuit of chemistry. Her distinctions include, but are not limited to, the National Medal of Technology, the Perkin Medal, the Chemical Pioneer Award, the Lavoisier Medal for Outstanding Technical Achievement, and she was even inducted into the Inventors Hall of Fame. So, her research made DuPont billions of dollars. And although she passed away in 2014, her legacy of inspiring women to engage in the sciences lives on.